Hello guys, welcome back to the second session of data structures. Hope the previous sessions have been fine and cool, and today you're ready to go for another kind of structure, queues. No wonder you might have experienced queues in day-to-day life, whether it's a grocery shop, movie ticket counter, or a reservation counter like this. Have you ever thought, why do we have to make a queue? Of course, for convenient processing so that everything is systematic and everything goes well without any chaos. When I say chaos, that means if I try to get in the middle of the queue here, will this young lady be going to give you a warm welcome? No way. Okay, so if a person wants to come in, yes, he is supposed to stand or join at the end of the queue. Also, you can notice that the person who comes first always gets the opportunity to move out also. So if I think queue itself is another kind of structure made for systematic data processing with some constraint, with some restriction, right? That adding of the elements happens at the rear end, whereas the deletions happens at the front or at the beginning. Cool. So if I define queues in terms of Python, a queue always have two ends, front and the rear. The insertions happens at the rear end, whereas the deletions happens from the front. It also follows FIFO structure. FIFO means first in, first out structure. Why? Because the element who gets in first has the opportunity to move out first. As we can see, 20 was there. 20 was the first element who was inside the queue. So 20 got the opportunity to move out first. Cool. So if I talk about the definition of a queue is a FIFO, first in, first out structure, where insertions and deletions happens at rear and front respectively. So since now you are clear with the definition, we can talk about some basic terms related to queue. They are NQ, DQ and the traversal. Insertion of an element at the end of the queue is termed as NQing, whereas removing an element from the front is termed as DQing. Cool. Traversal, as you know, it's iterating all the elements one by one. So here I will be iterating from the front till I reach the rear end of the queue. Now let us implement queues and program it out in Python. To create a queue in Python, we will be definitely using list. Okay, so I'll be creating a list. To do the enqueuing, I'll be using the append method, whereas for the dequeuing or the deletion, I'll be using the pop. But you can see pop is having the index number 0 because the first element has to be deleted here. Cool. And of course for the traversal there will be a for loop which will have the range functions from index number 0 to n-1th element. Okay, so let's proceed to create a queue of customers right now. So since it's going to be a queue of customer, I'm naming my list as customer list. Fine. I have defined the function add customer which is taking this list. And I'm going to add a customer name to this list CUST by using which method? Append, because I need to add an element at the rear end of the queue. So appending is done and finally I'm printing the customer list. Fine. So second part, the second function DQ means removing an element from the front. So this is the customer, this gets removed, and again from the front I'll be removing this customer. And of course, when the queue is empty, you should display a empty message, right? To avoid that runtime error. So again, same with the case of stack. Here I am taking the customer list, checking whether it gets empty or not during the deletion. If it gets empty, I am giving a message, sorry, the queue is empty. Fine. Otherwise, of course, elements are there and you can go ahead with the popping. But remember, I am deleting the first customer, so the index number given is 0. And if you want to print the name of the customer, you can definitely go ahead with a print statement. Fine. So the third operation, traversal, of course will be done using a for loop for I in range from the 0th position till you reach the n minus 1th element. So since n minus 1 has to be included, I'll be going one step ahead and including n over here. Fine. So for I in range 0 to n, and then I is the index number, so cust is the list name, so I have to write cust of I. I is the index number. If you print I, you will get only 0, 1, 2, 3 and minus 1. So be very careful. You have to write cust of I to print the names of the customer. And what is n? Of course, the total number of elements in the list. Fine. So traversal is also clear over here. Now let us look at the coding part. So you can see I have completed the entire set of code with the add customer, with the delete customer, and of course the traversal. Now let me just check how it is going to work out. Fine. So let me begin with adding a customer. Add customer, because there is no customer, let me add one. And where? Of course the list. This name is cust. Okay. Anu, and then see the Anu gets added to the list. Add customer, and again I'm calling cust, and say Binu is getting added again at the rear end of the queue. You can see Anu and Binu are there. Now let me just traverse it. So customer and okay. So the customers you can see from the beginning I have traversed. Anu is there and Binu comes over there. Cool. Now let's do some deletion. Delete customer and take the customer list. Who gets deleted? Yes, of course, the front. The first customer gets deleted. Anu is there. Again, I'm calling delete customer. Now who is left out? Yes, Binu is left out. Binu is deleted. Let me call it again. Customer, and then you can see queue is empty. Cool. So there is no runtime error. My code is perfectly okay. All the three functions are working properly. Now it's time to give you an assignment. You're going to collect all these functions and put together to create a menu driven program to perform all the operations of the queue. Fine. Hands-on experience is very important. Make sure that you do it and get the experience of creating queues. So that comes to the end of this session, but before we leave, as usual, it's time to recap. All the definitions are, yes, very important. The first one is a queue. Queue is a FIFO data structure where insertions and deletions takes place at two separate ends. Cool. And what are the separate ends? Rear and front respectively. Okay, adding an element in the rear end of the queue is enqueuing, whereas deleting an element from the front of the queue is dequeuing. Next is the underflow. If I try to delete an element from an empty queue, it's underflow condition. Okay. So that brings us to the end of this session, and if you've really followed well, enjoyed learning, put a comment. Data structures went great. Okay, so what are we waiting for? Grab your computer, start practicing, enjoy learning, and of course, happy coding.